Okay, this is a short little lecture in which we compare the natural log of x plus 1 and the square root of x. It's useful in a number of ways. I think it's a nice example of what we just proved as an application of the mean value theorem. I like it because if you sketch a graph of each of these curves, just sketch, not plot points, but just sketch at least in the for the positive x-axis they look the same. Okay, but in fact they're not, and let's see how that works. So first let's put f of x equal to the square root of x and g of x equal the natural log of x plus 1. Okay, we can then calculate that f prime of x is 1 over 2 times the square root of x, and that g prime of x is 1 over x plus 1. Okay, now consider if we take g prime of x minus f prime of x. We do our algebra, okay, and I thought this step was cool, that we can actually, the numerator is actually a perfect square, and so the numerator therefore is non-negative. The denominator is easily seen to be non-negative for values of x greater than 0, and so therefore f prime of x minus g prime of x is greater than or equal to 0. So by a corollary of the mean value theorem, it will follow that f of x minus g of x is greater than or equal to 0 for all positive values of x, and therefore as a consequence of this, the square root of x is bigger than the natural log of x plus 1. Okay, since the natural log of x plus 1 is greater than the natural log of x, it follows that the natural log of, that the square root of x is bigger than the natural log of x2. So you get that just for free.